Hi everybody and welcome to the OpenStack.Ninja YouTube channel. This video is a Keystone overview. Just a quick thing, a little bit about me. So I've been working in IT now for over 15 years. Been working with OpenStack and Ceph for roughly 5.5 years now. I've designed and implemented multiple OpenStack regions, both for public cloud and private cloud. And I mainly work with Red Hat OpenStack. That may mean that some of the information that I provide is slightly biased towards the Red Hat way of doing things, but I will try and be as kind of generic as possible. As with everything on the internet, everything I tell you in this video, I aim to be as accurate as possible, but obviously mistakes do happen. If you do spot something that's wrong with the information I provide, please do feel free to reach out to me, either comment in the video or you can email me. The email address is on my YouTube channel. So yeah, without further ado, let's have a look at the topics that we're going to talk about today. So this video is very much about what Keystone is and what function it provides inside an OpenStack cloud. It's not designed as an installation guide, it's not designed as a troubleshooting guide, it's more to give you an understanding of what OpenStack Keystone is used for. So the very first thing we're going to talk about is what is Keystone. We'll then move on to talk about the Keystone API, which is how you'll be mostly interacting with Keystone. We'll talk about some of the key terminology that you'll need to understand in order to be able to make use of Keystone and to understand it. We'll talk about its hierarchy. We'll then move on to talk about Keystone domains, Keystone token scope, and also token types. We'll also cover authentication, Auth Providers. And we'll also then move on to talking about the Keystone service discovery and endpoint catalog. And then finally we'll take a look at where the main config files are so that you can find them, and we'll also take a quick look at where the log files are and what those log files contain. So first off, what is Keystone? Keystone provides client authentication and authorization and service discovery. So any user of the OpenStack platform will authenticate against Keystone. Keystone will also possibly provide the authorization, and it will also provide service discovery so that clients know where to go in order to connect to the right endpoints in order to access the services that they require. That also includes internal services, so internal services will also use the service discovery service provided by the Identity API to discover where the additional components they need access to are. Keystone provides the controls that allow OpenStack to be a full multi-tenant service, so it provides separation in domains and in namespaces, and we'll talk about that in a little while. All client requests, both service requests and end user requests, will be authenticated and authorized via Keystone. And again, as I said previously, clients and services can use Keystone to locate services that they require. So it allows the creation and management of users, groups and domains, which we'll talk about later on. It also provides role-based access control for all other services. It allows you to integrate with other authentication sources such as LDAP, Active Directory and single sign-on services. And it also provides the ability for external services to be trusted to perform actions on behalf of a user. And again, we'll cover that a bit later on. Keystone, like the majority of OpenStack projects, is a Python application. It's served as a WSGI application and is served via a web browser. Its sole function is to provide the Identity API. And obviously, in order to be served, it relies on a web server, and for data storage, it relies on the database server. So now let's have a talk about API versions. So there are two major versions of the Identity API, version 2 and version 3. V2 has been unsupported and depreciated as of the Queen's release of OpenStack, which now means that version 3 is the default. Version 3 builds on top of the version 2 API and provides additional functionality, including domains, and it also consolidates the public and admin endpoints into a single endpoint. So prior to version 3, the version 2 API used to have to connect to one port for admin and one port for public, which obviously made your firewall configuration, your external firewall configuration, slightly more complicated. That's now been condensed down into a single port. So now we're going to quickly move on to Keystone Terminology. Now the terminology in Keystone is important so that you can understand when you're talking to other people about Keystone, or if you're you're reading the documentation, an understanding of the terminology is really useful. So I'm going to very quickly run through this. So authentication. So authentication is the process of determining if a user is who they claim to be. So that's generally the first part of a login sequence, where you present a username and a credential, be it a password or a one-time code or a certificate. You present that to Keystone. Keystone then checks that internally and says, yes, you are who you say you are, or at least you are you have the correct username and password in order to be let in. Authorization, which is another step in the kind of the login process, is the process of determining if an authenticated user is allowed to do what they're requesting. So whilst you may have an account on an OpenStack platform, you may not have access to perform different tasks. So as a standard user, you might not be able to see details of hypervisors, as that is outside of your authorization. So the process of authorizing your account is to check that the action that you're attempting to perform is one that you're allowed to do. That ties nicely into scope. So the scope is an operating context of a token, and we'll speak about tokens a bit further down. But a token, the scope is basically which parts of an OpenStack platform do you have access to look at. So for instance, an authenticated and authorized user who has permission to work just on a project would be said to have a token that is scoped to that single project. We'll come back to that in a minute because that can be a little bit confusing. Anytime somebody talks about services in relation to Keystone, they're generally talking about services like Nova and Neutron, or one of the other OpenStack services, so Cinder or Glance. Domains. So a domain is a container for users, groups and projects. So it's just a holder so that you can have multiple domains. So the reason you would want multiple domains is that a user could exist in two places. So a user could exist inside Keystone's internal authentication service, but could also have an LDAP integrated account. Now, without domains, those usernames may overlap, and that would obviously cause a problem. But using domains, you're able to create separate namespaces for users, groups, and projects, which allows the users, groups, and projects to be unique only inside that domain. So you couldn't have the same username inside. The same username could not appear twice in the same domain, but that username could appear inside a different domain, and then you wouldn't have a clash. And we'll talk more about domains in a moment. Project. So a project is a container or a namespace for OpenStack resources. So resources created in one project are separated from resources in another project. This is what starts to give OpenStack its ability to do multi-tenancy. So by being able to access one project, you can see one project's instances, its networks, its images that are created, etc. But you're unable to see what's in project B because you don't have access to project B. Users and groups, in order to access a project, have to have a role assignment, and we'll talk about role assignments a bit further down. So a role is just a representation of permissions. So generally you have, out of the box, 3 different roles inside OpenStack. You have admin, member, and reader. And a role is just those roles are just representations of permissions. So an admin user obviously has higher privileges than a member user, but each of those roles individually is just a collection of permissions that dictates what you can and can't do on an OpenStack platform. Role assignments is just the association between an actor and target. So an actor in OpenStack can be classed as a user or group, and a target can be a project or a domain or the entire system. So when we say a role assignment, we're saying that we're taking an actor, so a user, and giving them the role assignment of member on a specific project, which means that that user can then interact with that specific project, and based on their role, that has been assigned to them, they're allowed to perform a set number of tasks. And obviously, depending on which role you associate, dictates which actions they can perform. And this gives Keystone the ability to really fine-grain that access control. So you can create a role that only allows people to look at specific items inside a project. So you could say that user A has a role that only grants them the ability to see that instances exist inside a project, but they can't interact with them. So role assignment is really important. It's how you kind of control which users have access to which projects or domains or systems. It can also be done through groups, so you can assign a role to a group, and then you can assign users to those groups, and they obviously then inherit. So a token, which we spoke about earlier. So a token is a resource that contains the user's authentication and can also contain the user's authorization. This allows users to interact with OpenStack services. So a token is a representation of a user's authorization and authentication. It's what you get back from Keystone when you log in and you complete a login process. And that token will contain all of the information required in order for you to interact with other OpenStack services. Both Horizon, the web GUI, and the CLI command line tools, they automatically handle passing that token to different services. But if you're operating in an environment where you're making use of curl, you would have to first of all authenticate with Keystone, it would return a token to you, and then you'd have to pass that token to each of the services on every request. Every time you pass that token to an OpenStack service, that token contains the information that allows that service to decide whether or not you're allowed to make those to perform those actions that you're requesting. A user is just a representation of an end user of the platform, and that users can also be internal service users. So when an OpenStack service is talking to another OpenStack service, it talks to that service as a user, but that user obviously has different permissions to a standard kind of end client user. And then a group as I spoke about earlier, is a container for users. So you can put users into groups, and then you can use those groups to allow inheritance of authorization from roles that are applied to those groups. So that covers the kind of basic Keystone terminology that you'll need to understand in order to understand how Keystone operates. So very quickly, let's just talk about Keystone Hierarchy. It's not that difficult. Generally what you'll have is the kind of light yellow color would be a system. Inside a system you would have either a default domain or multiple domains. So here we've got a default domain. Inside the default domain we've got 3 projects: admin, service and widgets 1. And then we have Bob user, a Mike user and a widget group. They all exist inside that default domain. We then have a corp.local domain. Now that corp.local domain could be LDAP backed, it could be AD backed, it could be OpenIDC, it could be SAML backed. Doesn't matter, it's completely separate. It's a container that contains these other projects. So again, there's an ERP project, a billing project, a demo project, and then we've got a Bob Corp user and a Mike Corp user. Now those users could share the same username, but depending on which domain you pass in when you're authenticating would determine which account it tries to use to log you in. So here you can see why kind of domains are important, and again we'll cover that shortly. So let's move on and talk about domains. So domains were introduced in the v3 API to provide additional flexibility to the identity system. As OpenStack grew, people started to realize that they needed to have they may need multiple authentication sources. People were running into collisions with users and groups. So the idea was to introduce a system called domains. As I said previously, each domain provides its own namespace, and inside those namespaces, users, projects and groups need to be unique. But the separation allows for those objects, for users, projects and groups, to be they don't need to be system-wide unique because they're contained within a domain. And multiple domains, they allow you to have segregated users from multiple sources. So generally you will have, when you install OpenStack, you'll have a default domain which is associated to Keystone and uses Keystone to control its users, and they're usually SQL backed, so they exist in the SQL service. But then you may decide that, well, actually I've already got a corporate domain controller, I've already got a corporate Active Directory service or a corporate LDAP service, and I don't really want to have to manage all of my users in a second place. So what you can do is create a new domain, and you can link that domain to LDAP or AD or Federation and import those, and those users in that domain can then be given authorization to act against projects in a domain inside OpenStack. So instead of having to having to double up on your administration of managing users and that kind of thing in Keystone, you can leave that as being managed by your team that's responsible for Active Directory and LDAP, and just using Keystone you can just pass those authorizations through and set up groups and stuff that allow those users to log in using their corporate AD or their LDAP usernames and passwords and interact with the OpenStack platform. You will always have a Keystone-backed set of users because it would make no sense to have your service accounts and your primary admin account reliant on an external service in case for any reason that LDAP went down or AD broke. Obviously, you wouldn't want to be locked out of the management of the platform, and you also wouldn't want the platform to not be able to authenticate those service accounts, because that would obviously cause issues with your OpenStack platform. So by default, there is a default domain created during installation. That also allows backwards compatibility with the V2 API. So on some old OpenStack platforms, you may find that both V2 and V3 API are in use. The V2 API won't be able to deal with any users that exist outside of the default domain because it only knows about the default domain. So it was a shim introduced in order to keep backwards compatibility. The majority of new installations will probably only have the V3 API. So yeah, it's just something to be aware of. So we'll just move on to token scope now. So as I said, tokens are what you pass around the OpenStack platform in order to give authorization to perform actions. Now there are 4 levels of token scope, and we'll just quickly talk about those and what they're used for. So there's an unscoped token. So these are tokens that just prove that a user is who they say they are. They don't provide any authorization to perform any actions on the platform. They are just there to say that this user has at least completed and has at least authenticated to say they are who they are. These tokens can then be exchanged to provide a scoped token, and once they've been exchanged for a scoped token, as long as the user has the authorization to act at that level of scope, then their token will no longer be unscoped. It will then be one of the other 3 types of token. So the highest level of scoping is at the system level. So that allows you to look at pretty much everything. So a system scoped token allows you to drill down all of the hierarchies and see everything underneath with it. It also allows you to interact with things that don't exist inside kind of a domain or a project. So we're talking about services, we're talking about endpoints, and we're talking about hypervisors. Generally, normal users won't have access to the system scope. It's generally used for administration, and that's where and so you would have when you're interacting with the Nova service and you want to look at the state of a hypervisor, you would need a system scoped token in order to do that. The next step down is a domain scoped token, and that allows you to interact with items that exist outside of project scopes. So that can sometimes be users and groups, and it also allows you to look at any projects that exist below that domain. So you may be given a domain scoped token where you wish to look at the names of all the projects that exist in that domain. That generally would be a domain scope token, and it would allow you to list those domains. Beneath the domain scope token, you have a project scoped token, and now a project is kind of the lowest level of scoping. It allows you to look at the items that exist within a project, provided you have a role assignment that says you can. And this is generally where the most users will end up with a project scope token. It allows you to build instances, look at volumes, look at images, etc., etc. Generally, most non-admin users will be working with project scopes tokens, and they will be restricted to working on a single project using that token. Doesn't mean they can't switch projects, and when they switch projects, their token is exchanged for another project scoped token that now is scoped to the new project. So as I said, most non-admin users will be working with project scoped tokens. The good thing about token scope is that it generally takes care of itself, but it is very useful to understand the different levels of scoping in case you run into a situation where you need to understand it in order to troubleshoot a problem. So just as a kind of a visual aid with regards to token scoping. So on the left we have user 1. Now they could get a system-wide scoped token, which would allow them to look at the stats for the hypervisors and the endpoints. They could receive a default. They could receive a domain scoped token, scoped to the default domain, which would allow them to look at, the widgets 1 project and the widgets 2 project. It would also let them look at any users that also exist inside that domain. And then they could also get a scoped token for the widgets 1 project, which would allow them to look at instance 1, volume 1 and network 1. Or they could have a widgets 2 project scoped token, which would allow them to look at instance 2, volume 2 and network 2. So that just kind of helps to explain what we mean by scope. So let's quickly talk about the types of tokens that exist. So this is separate to token types. This is separate to token scopes. These are the actual tokens themselves rather than kind of what scoping there are. So there are 3 types of tokens that exist in OpenStack. Which one is in use will very much depend on your choice of installation and how old your OpenStack platform is. So the very first type of token that was implemented in OpenStack was a Uuid token. It was a 32-bit Uuid, and it was persisted in the database. So every time somebody did something that required a token and a token was issued, it was actually stored in the Keystone database, and this could cause that Keystone database to grow quite significantly. If you think every time something happens and a token is required and a token is given back to an end user, and it has to be stored without kind of database maintenance taking place, that can grow really large. So as of Pike, that's been depreciated. So unless you may find that kind of Mitaka, Liberty, those kind of older OpenStack platforms may still be using Uuid tokens, but they are currently depreciated as of Pike. So the second type of token that exists in OpenStack are Fernet Tokens. So they were introduced in Kilo, and I think they've been the default style since Queens. Now these are not database backed, so instead of being stored in the database, all of the information is kept inside the token itself, and they're secured using public-private keys. So the token is only decryptable by somebody who has the private key. That will be your OpenStack Keystone instance. If you obviously don't want to lose that private key, because that meant that somebody could sign one of the sign their own tokens. But it means that they have to be like I say, they are no longer database stored, so the large growth of that Keystone token table goes away. They're very secure, they use PKI. And again, they still have to be presented to Keystone for validation. And instead of storing that data in the database, the data is stored in the actual token itself. One thing to note is that with Fernet tokens, those keys that are used to sign those tokens should be rotated periodically. In case you ever have a situation where those keys are compromised, you should rotate your keys so that the impact is lessened. The great thing about Fernet tokens is, if you were to ever experience a situation where those keys were fully compromised, you can simply remove them, generate new keys, and that will automatically invalidate any Fernet tokens that were signed using those other keys. The final type is JWS tokens, so JSON Web Signature tokens. Again, they're not database backed. I've personally never worked with them, and I've never seen them. I've never seen an OpenStack platform deployed with JWS tokens, so I'm not 100% up to speed on why somebody would use JWS over Fernet, but it's included there for your knowledge. Like I say, Fernet tokens are the default. As long as you remember to rotate those keys periodically. I think most distributions recommend monthly, and that obviously keeps those tokens secure. Okay, so that was tokens. Now we're going to switch gears slightly and talk about Auth Providers. So an Auth Provider is something that provides authentication and authorization to the OpenStack platform. Now, Keystone on its own can operate as an authentication and authorization provider without any external dependencies. So when you stand up an OpenStack cloud platform, you will have Keystone running as an authentication and authorization provider, and at that point you can create users, create groups, create domains, assign roles, create roles, do everything you would need to do to operate your cloud. If you're working in a greenfield site, so you're a brand new organization that hasn't got any other infrastructure in place, that may be fine. If on the other hand you're putting an OpenStack platform into an organization that already has corporate AD or corporate LDAP services, or even a corporate even a corporate single sign-on service, you won't want to have to manage your users and groups in another location. So what Keystone can be done, what you can do with Keystone is you can actually link Keystone into an LDAP service or an AD service. And there's two ways when you're linking with AD or LDAP. There's two ways you can do this. You can have Keystone just for authentication. So what I mean by that is you will provide an LDAP or an AD username and password to Keystone. Keystone will go off to your AD or LDAP server and go, I've been given this username and password combo, is it correct? And it will come back and say yes or no. And that's the extent of the integration. It will just be checking that you are who you say you are. You would then use Keystone to manage your users, manage your group memberships and your project memberships and your role assignments. Second way that you can make use of LDAP that's linked with the second way you can make use of Keystone linked with LDAP or AD is where it's used for it uses the LDAP and AD backend for both authentication and authorization. So that means your kind of group hierarchies that exist in LDAP and AD are brought down into OpenStack, and then you can say that a member of the developer team will have access to these projects, and that's done and all your group assignments are done in LDAP and AD, and all you do is link those groups and you link those groups down into a project on OpenStack and give them access that way. So straight away you can deploy an OpenStack platform, link it to LDAP and AD, and an entire section of administration is removed immediately. You don't need to worry about creating users, they already exist. So any workflows that you have that automatically disable or enable users if they leave or if they go on maternity or whatever. That's all taken care of because it's handled on the LDAP AD side rather than on the OpenStack Keystone side. Keystone, so on top of AD and LDAP integration, Keystone can also be configured to work with IDP services via SAML2 or OpenID Connect. So if you've got a Red Hat Keycloak service that's serving single sign-on across the rest of your infrastructure, or you've got a SAML2 service that's providing that same feature, Keystone can work with both of those. Again, making use of existing authentication or authorization infrastructure to provide that single sign-on experience. So there's two ways there that you can do it. Keystone can also be connected to another Keystone service, where you could have a master Keystone service that isn't necessarily deployed into an OpenStack platform, but it's just Keystone, and you could manage it that way as well. I've generally seen platforms managed with all three of these. There are other Auth providers available as well. So moving on to one of the final pieces of the presentation today, service discovery. So OpenStack services tend to all be on the same, all tend to sit on the same FQDN, but on different ports. Now, this was obviously a design consideration that was taken early days. One way that this could have been done is you could have had multiple subdomains for the different services, and then you wouldn't have needed the ports. But the decision was made that they would go with different ports for the different OpenStack services. So what I mean is that, for instance, Keystone, if it's SSL encrypted, could exist on 1300. Nova could be on 13885. Now, if you were without a service discovery service that the Identity API provides, you would have to know all of those endpoints, and you'd have to have them in a file somewhere. So what Keystone provides is a way for services and end users to retrieve an endpoint catalog, which explains which ports all the other services exist on. This is really good. So that means that things like the OpenStack command line tooling, you just have to give it a username, a password, and an auth URL, and it can automatically discover all the other services. So when you run a command to query instances, it will go and get that catalog, find the compute instance, and then automatically talk to that endpoint. It also helps internally, so that services that rely on other OpenStack services are able to automatically discover those services without having them hard-coded in configuration files, which means if you change something, you only have to change it in the service catalog. You don't have to change it in the myriad of configuration files that may exist. So it's a really interesting, a really cool piece of service. So like I say, generally in order to make use of service discovery, you only need to give the command line tools or the other services that are using it a few pieces of information rather than kind of an entire list of different services. When you query the service catalog endpoint, you'll generally be returned 3 endpoints: a public endpoint, an internal endpoint, and an admin endpoint. Some services will return the same endpoint for all three. So Keystone now will generally return the public, internal, and admin as the same endpoint. Previously on the V2 API, it may return an external address for the public and an internal, and then the internal and admin. The internal one may be like an internal address range on the same port as the public, but then the admin might be an internal IP address with a different port number. The majority of services now, public, internal, and admin, tend to be the same, although it can differ depending on how you've decided to deploy your platform. So some people have deployed their services where they want internal users to connect to one IP address, to one FQDN, and then their public users to connect to a different one. Again, it's entirely down to the operator's choice. When you're using things like the OpenStack command line tools, the SDK, they will usually use the service catalog in order to kind of identify where they need to speak to. With the command line tools and the SDK, you can actually say that you want to talk to the public interface, you want to talk to the internal interface, you want to talk to the admin interface, and that's where it will get that information from. That's not to say that all services make use of the endpoint configuration. So some deployments will still have the services that they require. So some services will still have those endpoints hard coded. Just depends on how the configuration is done on the platform. So one thing that can then slightly affect service discovery is OpenStack Regions. So an OpenStack region is a full deploy of OpenStack. So Neutron, Nova, Glance, Cinder, etc. But with a shared Keystone and Horizon service. Now this allows you to have a single authentication and authorization, a single web GUI. But obviously you want to split those two platforms into the two separate instances that they are. So that is what a region would be. So when you speak to a service that has multiple regions, you will generally have to also provide the region identifier when making calls to those endpoints. So generally when you deploy an OpenStack region, when you deploy an OpenStack cloud platform, I should say, it will create a default region of region 1. All of the tooling generally will pass region 1 through as the default if you don't specify a region when you're using those tools. If you're in a position where you have multiple regions using a shared Keystone and Horizon, and you'd have region 1, and then the next one you deploy would be region 2. If you want to interact with Nova in region 2, you would have to specify when you ask the endpoint catalog in Keystone, you would have to ask it for region 2. If you left it default or you didn't put anything in, and it would just use the default, which would be region 1. I've never worked in an environment with multiple regions deployed like this, but somewhere out there I'm sure there are some platforms like that. Okay, so we're just going to quickly touch on the configuration files that exist when it comes to Keystone. Generally you're going to have two files. Now these files will exist somewhere on your deployment, and it depends on how your OpenStack platform is deployed, whether or not it's containers, whether or not it's OOO, whether or not it's Collar, whether or not it's OpenStack Ansible deployed, will dictate where they exist. But generally you're going to find two files that are of interest to you. You're going to find the keystone.conf file, which is the main configuration file for Keystone. It's a big, huge file full of hundreds and hundreds of options, all in one place, but it is broken up into sections, and I recommend using crudini, which is a command line tool to allow you to find things in those configuration files easily. In the keystone.conf file is where you're going to do the majority of your configuration of Keystone. It's where you're going to tell it where the database server is. It's where you're going to tell it if you're going to connect it to LDAP or AD. It's in that file that you're going to make those changes. And you're also then going to find a file called policy.yaml. So policy.yaml is a representation of access controls for the Keystone service. So whilst inside OpenStack you have roles and all that kind of stuff, you can also then use these policy.yaml files to fine-grain some of the access controls for that Keystone service itself. Policy.yaml files are again fairly complicated and require a little bit of thought. If you make a change to a policy.yaml file, you could end up locking yourself out of your platform. So just be careful when you're working with policy.yaml. But yeah, like I say, it's there. So again, keystone.conf, that's where you're going to be doing your, so if you're building something from scratch, keystone.conf is going to be the place that you're going to spend most of your time configuring. Policy.yaml, generally out of the box, will normally be okay. There may be a few occasions where you need to go in and make changes to that. And like I say, the keystone.conf file is split up into a hierarchical list of different configuration options. Each section, there'll be a square bracket and then the section name and a square bracket. That section exists all the way down to the next square bracket, section name square bracket, so you can work out which items need to be modified for your install. If you go to the OpenStack documentation, you can find example keystone.conf files. Worth having a read through those. Like I say, there are hundreds of different configuration options that are there, but they're the main configuration files. So the documentation is there, docs.openstack.org. Obviously that points at the latest. If you're looking for a specific version, you can normally replace where it says latest with the name of that release. But if not, just head to docs.openstack.org and there'll be a drop down at the top. So we're very quickly going to talk about Keystone log files now. Again, this isn't a troubleshooting video. That will hopefully happen in a future video. But it's worth knowing where the application log is going to live. So generally, you've got three logs that you need to keep an eye on. You've got keystone.log, which is generally the inner workings of the application. So in there, you're going to see, if Keystone won't start, in there is where you're going to find the error message and the Python backtrace to tell you what's happened. Anything to do with the actual inner workings of Keystone itself, that's where it's going to be. That's going to be in your standard logging locations of either varlog Keystone, or if it's a containerized deployment, it may be in varlog containers Keystone. That's generally your first stop. If you're having an authentication issue, generally you need to go in there. You may find that the information you need is hidden from you. Now, due to the confidential nature of the work that Keystone performs on behalf of an OpenStack platform, there's an additional debug setting. So generally you have debug, which you can set to true or false in the keystone.conf file. With Keystone, when you set debug to true, you get 90% of your debug messages, but anything sensitive will still be omitted. You also have another option called insecure debug, and if you set that to true, it will log absolutely everything, including things like passwords and anything that's confidential about your platform. So you may find that if you're troubleshooting a problem, you may need to enable those options, but be aware that with insecure debug set to true, you are outputting confidential and possibly damaging information if it was to be leaked. And you've also then got the Whiskey application logs, and then generally going to be found in the log directory for Apache or HTTPD. Generally they're called something like Whiskey Keystone admin and Whiskey Keystone main. The differences there are that the admin log contains details about admin endpoint activities, and the main log contains details about public endpoint activities. So admin endpoint activities are going to be things like possibly things like creations and deletions, etc. The public endpoint is going to be things like authentication or authorization requests. And these logs contain information about the web from the web server's point of view. So any time that the Whiskey service is performing something on behalf of the application and something goes wrong, that's where that's going to get logged. Again, generally start with the Keystone log. It's always worth looking in the Whiskey application logs in case there's something in there as well. So that brings us to the end of this overview of Keystone for OpenStack. I hope you've enjoyed and I hope it's been useful. If you have enjoyed it, please leave a like and possibly subscribe to the channel. There's going to be new videos following the same sort of format, hopefully for all of the upcoming, OpenStack services. But again, thank you for watching.